In the wintertime, we're essentially extracting heat from the earth and using that heat as a baseline for very efficient heating. And in the summertime, we're dumping heat from the building into the earth in order to provide very efficient cooling. And the end result is a system that's 3 to 5 times more efficient than conventional HVAC, but it's fully electric. There's no combustion, there's no emissions. There's no rooftop condensing units, which you so often see on commercial and multifamily buildings. It's just clean, quiet, consistent energy transfer to fully condition the building to desired temperatures.
Welcome to CRE Radio for influential commercial real estate professionals who work with investors, buyers, and sellers of commercial real estate coast to coast. Whether you're an investor, broker, lender, property manager, attorney, or accountant, we're here to learn from the experts.
Welcome to Commercial Real Estate Pro Network's CRE Radio. Thanks for joining us. My name is J. Darren Gross. This is a podcast focused on commercial real estate investment and risk management strategies. Weekly, we have conversations with commercial real estate investors and professionals who provide their experience and insight to help you grow your real estate portfolio. Today's interview is sponsored by Building Insurance and Risk. When you invest in real estate, it pays to work with a real estate investor protection specialist to protect yourself and your investment from catastrophic loss. The experts at Building Insurance and Risk focus on real estate investor protection. They provide you with multiple insurance coverage offers and a side-by-side coverage comparison. To learn more, go to buildinginsurancerisk.com. Today, my guest is Bryan Roberts. Bryan Roberts is with Dandelion, where he serves as Director of Business Development. And in just a minute, we're going to speak with Bryan Roberts about high-performance earth-powered geothermal heating and cooling. But first, a quick reminder, if you like our show, CRE Radio, there are a couple things you can do to help us out. You can like, share, and subscribe. And as always, we encourage you to leave a comment. We love to hear from our listeners. Also, if you want to see how handsome our guests are, be sure to check out our YouTube channel. You can find us on YouTube at Commercial Real Estate Pro Network. And while you're there, please subscribe. With that, I want to welcome my guest, Bryan Roberts. Welcome to CRE Radio.
Thank you so much. It's a pleasure to be here.
Well, I'm delighted to have you, and I'm looking forward to our conversation. But before we get started, if you could take just a minute and share with the listeners a little bit about your background.
Sure. Yeah, I'd be happy to. Well, if I go all the way back, if I may, for just a moment, when I was a child, I spent a lot of time on new home construction sites. My father was a contractor, and I would frequently spend time on the job sites watching him and his crew put up new homes from the ground up, from the foundation to framing and finish work. And that triggered a little spark for me. I found it really gratifying, honestly, even a little exciting to just see how buildings can go up so quickly. Sometimes over the course of just a few hours, the building would change shape. And that was influential, foundational for me. It gave me comfort in construction environments, as well as in interacting with contractors and tradespeoples. I, like most people after high school, or many people anyway, went on to college. And after I got my 4-year degree, I put my tool belt on as well and spent about a decade in new home construction. Again, building single family homes from framing to finish work, and got a lot of hands-on experience, learned how to interpret architectural and engineering schematics, and to extend the building metaphor, it started to put a structure atop the foundation that was put in place when I was a kid. The truth is, though, although I love building special places, creating durable, efficient spaces for people to live, high quality lifestyles, I didn't always want to be a carpenter for life. I went on to seek other experiences. I went back to grad school, got a master's degree in regional planning. And I saw that as an opportunity to sort of scale up my impact. Single family homes are great, but I only built one at a time. And regional planning was an opportunity to have impact on a community scale. I do love placemaking and helping to really enhance the environment we live in. And I did that for a handful of years working as a planning consultant, and then got what I consider to be an interesting and somewhat unique opportunity to join Tesla's energy division, their solar energy division. And at the time, I saw Tesla as a very exciting company doing, innovative, impactful things, and was very enthusiastic about that opportunity. Although it quickly led to another opportunity to join a startup called Dandelion that was launching with the intent of scaling geothermal HVAC systems, the most efficient HVAC system known to man, in a way that had really never been done before in this country. I had built some houses that had geothermal HVAC systems. I knew about them. I knew that they were it's a premium technology. And so I took the opportunity and joined the Dandelion team in early 2018. At the time, there were only about 20 employees across the entire organization. And we set out to deliver and scale geothermal in a way that hadn't been seen in this country before. And so 7 years later, here I am. We've made a lot of progress and have been involved in a lot of really fantastic projects. But the truth is, in many ways, we're just getting started, and there's a lot of really good work to do to deliver this technology to the masses.
Awesome. Well, maybe a good place to start is to just define what is geothermal.
Sure. Uh, at a high level, geothermal is a high efficiency HVAC system that uses the stable temperature underground to heat and cool buildings. It transfers energy through a buried loop system and an electric heat pump. So a little more specifically, there's three primary components of a geothermal heating and cooling system. You have the outside component, that's called the ground loop, and that's what we use to realize thermal exchange with the earth, and that's what makes the system so much more efficient than alternative heating and cooling systems. Inside the building, we have the heat pump. That replaces your conventional mechanical HVAC equipment, so you don't need a furnace or conventional air conditioner. And then you have the distribution system. Typically, that's ductwork. So you connect the heat pump to ductwork, and that's how you blow the conditioned air throughout the building to satisfy whatever the thermostat is calling for.
Got it. So you're basically getting the good, comfortable temperature like you feel in the basement air to blow throughout the building. Is that
Yeah,
fair?
that's right. In the wintertime, we're essentially extracting heat from the earth and using that heat as a baseline for very efficient heating. And in the summertime, we're dumping heat from the building into the earth in order to provide very efficient cooling. And the end result is a system that's 3 to 5 times more efficient than conventional HVAC, but it's fully electric. There's no combustion, there's no emissions. There's no rooftop condensing units, which you so often see on commercial and multifamily buildings. It's just clean, quiet, consistent energy transfer to fully condition the building to desired temperatures.
Got it. So the technology is how old is it?
Well, it's been around for decades. It is a proven technology. It when it's designed and installed well, it works exceptionally well. Um, but it hadn't been widely adopted up until recently. It's certainly scaling up now, but it's been around for decades. It wasn't widely adopted, and that's really what we're here to change, right? We want to deliver this technology to the masses, and we achieved that in part through innovation, but largely through scaling and standardizing in a way that really hasn't been done, at least in this country, on a residential level before.
Got it. And as far as the application, is it primarily new construction you're working with, or are you doing any retrofitting?
Yeah, when Dandelion first launched, we had a pretty specific focus on retrofit. We did some new construction projects, but primarily we were doing home retrofits, and we installed thousands of systems, retrofit systems, primarily here in the Northeast where I'm located. In the last couple years, we've shifted our focus towards at scale new residential construction, both single family and multifamily new construction. And we're now working on projects all over the country, primarily in three nodes in the Northeast, the DMV, Washington, D.C., Virginia area, and the Mountain West, Denver metro area. Although we're looking at projects and involved in projects in places such as Tennessee and Texas and Vermont, and the list goes on.
Well, speaking of location, is there a climate or is there a range of temperatures where this works best? Or, I mean, is there some latitudes where you find that it doesn't work?
Geothermal is viable in just about any location as long as you have an area to install the ground loop. We can realize thermal exchange. I think uh, we see ROIs that are more appealing in northern heating dominant climates. But the truth is, in southern air conditioning dominant climates where it's very hot, you're using a lot of energy there as well. And so geothermal can be very attractive in those climates too, because again, at the end of the day, this is the most efficient system, which means reduced energy consumption and reduced operating costs.
Got it. You mentioned the ground loop. Is there an equation to determine how big of an area you need to lay this loop in order to cool the structure you're attached to?
Yeah, it is a pretty precise calculation. There are a number of variables that come into play in that equation, which includes, the total heating and cooling load for the building that you're trying to or that you're going to condition. There's a direct correlation between the size of the ground loop and the size of the building loads. The local climate plays a role in the ground loop that's required. So too does the underlying geology, both the thermal conductivity of that geology is especially relevant. We're taking all of these variables into consideration to design a ground loop that is precisely suited to satisfy the heating and cooling needs of the building.
Is there an average depth that you have to go down to make this occur or to
Yeah,
install the system?
once you get about 10 to 15 feet down, you hit a pretty constant temperature. That constant temperature does vary depending on where you are geographically. Here in New York, where I'm located, once you get about 10 or 15 feet down, the Earth's temperature is around 55 degrees for hundreds and hundreds of feet. So we'll drill typically anywhere from 2 to 600 feet deep when we're installing vertical bores for the ground loop. Um, in places like Texas, you might see ground temperatures that are closer to 70 degrees once you get 10 or 15 feet down. Uh, but the same deal. We're drilling bores that are typically 2 to 600 feet deep, and we'll drill as many as we need in order to satisfy the heating and cooling load of the building. Maybe one point of clarity, I'm talking about drilling boreholes. These are not enormous boreholes. These are 5-inch diameter holes. And once we drill these holes, we put a pipe into them. It's a U-shaped pipe, so we can circulate liquid down one end and back up the other. And that's how we realize the thermal exchange, by circulating the liquid through the piping system. And once that pipe is in place, we backfill the borehole with an organic grout compound. It's a thermally conductive cement, essentially. And so that locks the pipe in place for the life of the system. So these are small holes. We put a pipe in there and then we just backfill it with this thermally conductive cement. And that ground loop should then last the better part of a century.
Got it. Well, the depth, the 15 feet sounds manageable. The hundreds of feet, and I'm like, wow. So I would assume that would kind of take out some of the high water table areas as far as a prospect for geothermal. Is that fair?
Well, it's very common for us to hit water when we're drilling vertically. It's actually not a problem. In a way, it's a good thing. Water is very thermally conductive. So if the loop or a portion of the loop is in water, we're getting really good thermal exchange. Um, the challenge it does pose is while we're drilling, just the need to manage water that might be coming up out of the hole. But we have various techniques for doing that. Yeah, active aquifers, subsurface aquifers won't scare us away. It's totally manageable.
Cool. I could, as I was preparing for this, I thought, oh, but there's certain areas I can't do it, kind of thing. But so, is there a preferred soil that you found that works best, or is it easier to install?
Well, we'll adapt our drilling techniques to subsurface conditions. Believe it or not, bedrock is highly desirable.
Hmm.
Uh, We can drill right through bedrock. It's thermally conductive, and we don't need steel casing to keep the hole intact. When you're drilling through soils, you're often going to need to insert steel casing in the ground to keep the hole intact, at least until you get the loop piping in place. In some instances, you can then extract that steel casing, and in other instances, you need to keep the steel casing in place. But with bedrock, we can drill a hole in the bedrock, the hole stays intact, and we don't need that steel casing. But yeah, as I mentioned, we can adapt our drilling technique to just about anywhere.
Got it. And then as far as you mentioned the loop, so I assume there's a down tube and an up tube connected at the bottom. Is that,
That's
am I,
right.
and then
Yeah,
is there a
yeah,
distance between the tubes or the holes?
right. So with a bore field, in some instances, for a single family home, you might only drill one bore that's maybe 500 feet deep or so, and it just has one U-bend pipe inserted into it, and you're done. When you're dealing with larger commercial projects or multifamily buildings, you're going to install many bores, sometimes hundreds of bores. Those bores typically are spaced, say, 15 to 20 feet apart. It's possible to put them closer together, but they start to have thermal exchange with each other when they get too close. So you do need some spacing. If you're going to put them closer than 15 or 20 feet apart, you're going to need to drill more linear feet of bore in order to make up for the thermal exchange between the bores.
Got it. Got it. So the space requirement then, I mean, I guess what I'm trying to understand is, so you go a couple hundred feet deep, you go 15 feet over, you got another one, and that kind of completes your loop. So how many square feet, just for reference, would you expect, an up and a down tube to be able to manage, and not any specific application, just in an average kind of a thing. Is that a
Yeah,
couple thousand square feet?
one 500 foot bore. Again, it depends on the like efficiency of the building envelope,
Uh-huh.
right? How many square feet can be accommodated by a single bore, but in the range of say 3 to 5,000 square feet.
Wow. Well, that that makes it a whole lot more manageable as opposed to, you know, I was wondering, okay, can you do this with one, or are you going to have like your whole, property with holes drilled in that? And then is there, obviously we talked about as you go deep, there's aquifer type issues or soil different soil issues. Um, is there any like when placing this, is it important to keep it away from where, vehicles would be traveling over it, or distance to the structure that are ideal?
Yeah, so believe it or not, we can, if in the context of new construction, where there's nothing on the ground yet, we can drill the bores in the building footprint before the foundation is laid, and then the foundation and the slab will be literally poured right over the bore field. We can also put bores in future parking lot or green spaces. Once we drill these bores, they're effectively cut off about 4 feet below the surface, and then they're going to run horizontally, again at that 4 foot depth or so, into the building and into the mechanical room where they're going to connect with the heat pumps. Um, and once those horizontal tie-ins are made, we backfill and bury the loop piping, and yeah, you can pave right over it and have future parking lot, or again, even the building built right on top of it.
So what's the reception you've received when talking with homeowners or developers or contractors that are going vertical, are they like, yeah, let's do it, or is there a what's been the reception?
Yeah, I mean, I think everyone is intrigued by this technology. They've heard of it, don't necessarily understand how it works. So, inevitably, there's the first part of the conversation is explaining clearly how the system works in terms of the thermal exchange and the heat pumps. I think most are very enthusiastic about the technology in that it literally is the most efficient heating and cooling system known to man, which means, again, you reduce your energy consumption, you reduce your carbon emissions, and you reduce your operating costs, which for commercial developers can also mean increase in asset value, and that's very attractive. Um, you know, uh, some of the barriers are just upfront costs because candidly, geothermal, unique to HVAC systems, requires a bore field. Others do not. Others entail just installing the equipment in the building. Geothermal entails installing equipment in the building, but we also have to put that ground loop in place. So we have to talk about upfront costs versus payback over time through operating cost savings is one way. Another way is, as I mentioned, increase in asset value. Another way is in eliminating the replacement cycles of conventional equipment. If you look at conventional air conditioners or air source heat pumps, they have condensers that are outside, exposed to the elements, and a pretty short lifespan. Depending on, I talked to some developers who, are in more coastal environments where there's a lot of salt in the air, and they're replacing rooftop condensers as often as every 5 years. And others who are in more northern climates and they have their equipment just getting beaten up by harsh winters, um, and are replacing their equipment, somewhere in the 10-year range. Ground source heat pumps or geothermal heat pumps, they sit entirely inside the building and have an expected lifespan of 25 plus years. So they're going to last 2 to 3 times, maybe even more in some instances, the life of conventional equipment. So when you account for operating cost savings, asset value increases, and eliminating replacement cycles, it's a pretty attractive value proposition. And then couple that with significant federal incentives. There are federal tax credits that help to offset the upfront costs, as well as in many states, there are state and utility rebates and/or tax credits that further help to offset the upfront costs.
Is there any risk of those being eliminated? I know there's a lot of big beautiful bill talk about different things being cut. Do you know of anything that's potentially affecting those those energy credits?
Yeah, we've been tracking it closely, and there's always concern about various incentives being, the rug being pulled out from under us. Fortunately, both the House and the Senate version of the big beautiful bill to date keep commercial tax credits in place for geothermal HVAC systems. And these tax credits, by the way, can amount to as much as 50% of the upfront cost, which is really quite significant. Coupled with, there is also unique to geothermal HVAC, what's called accelerated depreciation. Um, Conventional HVAC equipment depreciates over a straight line 39-year schedule, whereas geothermal uniquely qualifies for 5-year depreciation on the asset. So that's just a time value of money argument that is very beneficial to those who install the geothermal systems.
No, that sounds like a win for the commercial applications. Is there an ideal asset class, excuse me, that you tend to uh, be involved with?
Yeah, Dandelion is focused specifically on residential applications. So we work both in the single family as well as the multifamily arena. Um, as I mentioned, we've installed thousands of systems in the Northeast. we're currently involved in a really exciting project with Lennar, who I'm sure many of your listeners have heard of, top three builder in the nation, uh, deploying one of the largest, perhaps the largest, residential geothermal uh, um, operation on 1,700 homes over the next 2 years uh, in the Denver metro area. So we're thrilled about that project. Uh, Certainly one of the largest, and I think definitely the quickest deployment of residential geothermal in U.S. history. We're working on multifamily projects as well. We have one underway in Vermont now, others in New Jersey, DMV. Again, we're looking at some additional multifamily projects in Colorado, Tennessee, and other places around the country. But that's Dandelion's focus. It should be noted, though, that geothermal, I mean, there's about 1.5 million geothermal systems across the US, and they are in all kinds of facilities, ranging from Patrick's Cathedral in Manhattan to military and university dormitories. Even Fort Knox has geothermal heating and cooling in a portion of their facility. So there are a lot of applications. Really, any building is eligible.
Well, it sounds like an amazing system. I mean, you obviously the hurdle seems to be the upfront cost, but it seems like even with what we've discussed, there are ways to, help with that, whether it be the tax credits or the accelerated depreciation. Um, and the life expectancy of the system seems to be a win. And I'm curious. I mean, my expectation would be just the constant comfort of a system as opposed to the highs and lows of a traditional system. Do you find that?
That's exactly right. It's a great point. Um, with conventional, say, fuel-fired systems, right? They're heating the air to a very hot temperature, typically something in the range of, say, 180 or 160 degrees at the furnace. And by the time that air is coming out of the vent registers into the rooms you're in, it's still probably in the range of 130 degrees or so. So it's very hot, very dry. We all feel that in the winter. Our skin starts to dry out. Perhaps you're a little more thirsty than usual. With geothermal, it operates at cooler temperatures in order to satisfy what the thermostat is calling for. So by the time the air is coming out of the vent registers, it's more like 90 degrees. So significantly cooler air mass than conventional fuel-fired systems. That makes for a dramatically more comfortable environment. The air quality is better. It's not as dry. You're not as reliant on humidifiers in the wintertime. It also requires the system to run with more frequency. So the heat pump is pushing conditioned air into the space with more frequency because it's a cooler air mass. You essentially need more of it. So it's pushing air into the rooms a greater amount of time. That means you get better and more even distribution of that conditioned air throughout the room as well.
Does the design of the ventilation system change at all with a geothermal system?
It's pretty much identical to what you would install with a conventional system. You're going to use ductwork. It's going to take up just about the same amount of space with heat pumps, whether you're talking ground source, which is what Dandelion does, or air source. You need about 400 CFM cubic feet per minute of airflow per ton of heat load. So we're looking for 400 CFM per ton. That's more or less the case with a combined system where you have a fuel-fired furnace and a conventional air conditioner. You can get away with a little bit smaller CFM, so smaller dimensionally ductwork, but it's very close in size. So very similar.
And we talked about it just briefly, but I just want to make sure that so the extreme temperatures, so you get a below zero spell for a week or two. Is the geothermal system going to continue to be able to create a comfort air temperature for the occupants of the building?
Yeah, so we specifically design these systems to be able to satisfy peak load demands, which would be the coldest days in the middle of winter and the hottest days in the middle of summer. This is part of the calculations and the science behind designing a right size ground loop and specifying a right size heat pump. Um, so yeah, the short answer is absolutely. We can satisfy 100% of the conditioning needs of the building year round. I'll also note these heat pumps have the option for a backup electric resistance auxiliary heater. So if you want to have that as a security blanket in the instance of, extreme cold temperatures, you can have that auxiliary heater. If for any reason you need it, that aux will kick on and supply some additional heat. Um, so yeah, which by the way, you see that in air source heat pumps as well. They typically have backup electric auxiliary heaters. The only difference is air source does start to struggle as the temperatures get lower because air source heat pumps are using the outside ambient air temperature as a baseline for thermal transfer, whereas ground source uses the constant in-ground temperature as a baseline for thermal transfer. So you get consistent performance and efficiency with a ground source system because you're using that constant earth temperature, whereas an air source system, you get variable efficiency because it's using the variable outside air temperature. And air source heat pumps start to struggle in those colder temps and rely more heavily on backup auxiliary heaters.
Got it. So that's an important distinction because I think myself, not being fluent in heat pump, um, technology. Uh, so there's a distinction. There's the air source, and then there's the ground source as far as the styles of heat pump. Is that right?
Yeah, that's right. I'd say broadly, the name of the game when we talk about conditioning our buildings, we're moving towards electrification, right? And away from fuel-fired systems. And uh, in the arena of electrification, there's two options. There's air source heat pumps and there's ground source heat pumps. And air source heat pumps have their applications and are great where needed. But ground source is superior for a number of reasons. Most especially, they're more efficient, cheaper to operate, and the equipment lasts substantially longer.
Got it. Well, it's fascinating. I think the opportunity to have a long lasting, reliable, comfortable air system is attractive to anybody.
Yeah.
So I would hope this continues to grow and makes its way to the building you're in, because that sounds like a neat opportunity. And just having I grew up back in the Midwest. I just remember like everything you're talking about, the really cold and the dry and the static electricity and all that, and that the traditional system, it worked from a standpoint of making it comfortable, but it seems like there's definitely some room for some improvement there. So that's cool. Hey, Brian, if we could, I'd like to shift gears here for a second. Um, as I mentioned to you before we started, by day I'm an insurance broker, and as such, I work with my clients to assess risk and determine what to do with the risk. And there are three strategies we typically consider. We first look to see if there's a way we can avoid the risk. When that's not an option, we look to see if there's a way we can minimize the risk. And if we cannot avoid nor minimize, we look to see if there's a way we can transfer the risk. And that's what an insurance policy is. It's a risk transfer vehicle. And as such, I like to ask my guests if they can look at their own situation. It could be your clients, could be the technology, could be the economy, whatever it is that you identify and consider to be the biggest risk. And again, for clarification, while I am an insurance broker, I'm not necessarily looking for an insurance related answer. And so if you're willing, I'd like to ask you, Bryan Roberts, what is the biggest risk?
Yeah, of course. Um, the biggest risk. one of the biggest risks, I would say, for geothermal HVAC systems is late integration into the project. If a developer brings us in after the mechanical engineering, the MEP is finalized, or even well underway, we're often trying to retrofit a solution into a system that wasn't designed to support it. Um, there can at times be a little bit of a knowledge gap. Many architects and engineers will default to legacy HVAC systems simply because that's what they're most familiar with. And we see some missed opportunities because geothermal wasn't on the table early enough. So I would say it's really important that we get involved in the conversation early. That's a huge risk for us to not be involved early enough. On the flip side, if I look at it from the developer's perspective, those developers who don't go with geothermal, their risk is future obsolescence. You're looking with fossil fuel systems that may soon be out of code, that are unattractive to future buyers or burdened with expensive retrofit requirements. And on top of that, you're leaving major tax credits on the table that are available to offset the upfront costs and make it possible for you to enjoy lower operating costs over the long haul.
It's awesome. Bryan, where can listeners go if they'd like to learn more or connect with you?
Well, they can always reach out direct through our website, which is dandelionenergy.com. We also have a phone number listed on the website. So I'd encourage folks to reach out through the website, and you can mention that you're looking to connect with me directly if you are, and I'll be thrilled to chat with you.
Awesome. Well, Bryan Roberts, I can't say thanks enough for taking the time to talk today. I've enjoyed it, learned a lot, and look forward to doing it again soon.
Hey, likewise. Thanks so much. Been a real pleasure.
All right. For our listeners, if you like this episode, don't forget to like, share, and subscribe. Remember, the more you know, the more you grow. That's all we've got this week. Until next time, thanks for listening to Commercial Real Estate Pro Network's CREPN Radio.
You're listening to CREPN Radio for influential commercial real estate professionals. For more information on this or any of our guests, like us on Facebook, CREPN Radio.